Ever wished you could launch a complex computing task, kind of like ordering takeout? Just a few clicks and boom, it's running. No servers, no capacity headaches, none of that stuff. Well, get this. That's what we're diving into today. Serverless scheduling on AWS.
And when we say serverless, it doesn't actually mean there are no servers involved, right? It just means that someone else, in this case AWS, takes care of all the server headaches. Provisioning, scaling, patching, the works. It's all happening behind the scenes, so you don't have to. You can just focus on, well, actually getting work done.
Okay, yeah, sign me up for ditching the server headaches for sure.
Yeah.
But how does all this serverless magic actually work? I'm looking at this first diagram you sent over, and well, it's a lot to unpack.
Right. It lays out a whole system for running those complex jobs without you needing to babysit servers.
Ah,
It all starts with an EC2 instance. Basically, you're renting a powerful computer from AWS's cloud.
okay, makes sense.
But here's the thing. We're not just launching any old instance. We tag it with a specific keyword, scheduler queue.
Tagging it, is that like a digital sticky note or something? Something that tells AWS what that instance is for.
Perfect analogy. Yeah, it's like a digital sticky note. But more than that, it acts as a trigger. See, AWS has this service called CloudWatch, which is always watching, constantly monitoring your cloud resources. And when CloudWatch spots that scheduler queue tag, it knows, okay, this EC2 instance is ready to handle some tasks. Then CloudWatch sends an alert to a Lambda function, and that kicks off the next stage in the process.
Lambda functions, right, right. Always forget what those actually do.
No worries. Think of a Lambda function as a little piece of code sitting there in the cloud just waiting for a specific event to happen. In this case, that event is the CloudWatch alert triggered by our EC2 tag. Like dominoes, one action automatically triggers the next.
Dominoes, okay, I like that. So our EC2 instance is tagged and ready. CloudWatch is our first domino. It's tipped over. And now we've got our Lambda function springing into action. What's this particular function in charge of?
This Lambda function's job is to activate a step function state machine.
State machine, okay. Another new term.
Right, but think of it like the conductor of an orchestra, making sure all the different parts of our serverless system work together in harmony.
Okay, I'm with you. So instead of musicians, our conductor is coordinating serverless tasks.
Exactly, and those tasks are all organized in something called an SQS queue. Basically, a to-do list for our serverless setup. Each item on that list, that's a specific job waiting its turn to be executed.
So let me get this straight. We've got our tagged EC2 instance prepped and ready. Our Lambda function has called in the conductor.
Yeah.
And we've got a queue full of tasks just raring to go. What happens next?
Now our conductor, the state machine, takes center stage. It takes a task from the SQS queue, the top item on the to-do list, and tells the EC2 instance, all right, time to get to work. And here's the really cool part. The whole process is meticulously tracked. Every step, every update, even hiccups, all logged in real time to a DynamoDB table.
DynamoDB, it's a database, right?
Precisely. A database in the cloud, yeah.
Yeah.
So at any moment, you can see exactly what's happening, which tasks are running, which ones are complete, if any errors have popped up, all without needing to manually check on the EC2 instance itself.
So I can sit back and watch the serverless magic happen. That's way easier than I thought.
And that's not even the best part. The system is built for reliability. Remember our step function, our conductor. If our EC2 instance runs into a problem, the state machine doesn't panic. It just puts the task back in the queue where another available instance can pick it up.
No single point of failure. Yeah. The system just keeps chugging along. This is seriously impressive. I'm already thinking about tasks I could automate with this. This is great.
And that's just the tip of the iceberg with serverless computing. But imagine needing to run even more tasks. I'm talking hundreds, even thousands at the same time. That's where things get really interesting.
Okay, you've sold me on this whole serverless scheduling thing. But hundreds or even thousands of tasks at once. That sounds like it could get out of hand pretty quickly with just one EC2 instance.
You're telling me. And that's where scalability comes in. We need something, well, as flexible as it is efficient. It's kind of like, imagine you're having a small dinner party, right? And you've got one oven to cook everything. Works great for a few guests, but what happens when you need to cook for, like, 100 people? You're going to need a lot more ovens, and you're going to need them fast.
I see where you're going with this. And those extra ovens, in the serverless world, those are auto scaling groups.
Ding, ding, ding. You got it. Autoscaling groups, they're one of the things that makes serverless computing so powerful. They can automatically adjust the number of EC2 instances you've got running based on how much demand there is. So instead of one oven, you've got a whole kitchen full of them, all fired up and ready to go exactly when you need them.
Okay, so that's how it fits into this serverless scheduling picture.
Right.
But how does AWS just, know when to spin up those extra instances?
It's all about automation, setting things up in advance. With these auto-scaling groups, you basically set some ground rules for AWS to follow. You tell it, hey, I always need at least this many instances running, but if the queue starts to back up, feel free to spin up some more, but don't go over this number.
So I could say, keep at least 2 instances running at all times, but if things get busy, go ahead and spin up more, up to a max of 10, something like that.
Exactly. You're giving AWS the flexibility to adapt to how much work you're throwing at it without you needing to micromanage every single instance. Saves a ton of time, and it helps avoid those dreaded server overload situations.
Okay, this is starting to click now, but how does this auto-scaling magic work with the serverless scheduler we talked about? The psych diagram you sent, is this where the magic happens?
This diagram shows just how seamlessly auto-scaling groups work with the whole serverless scheduling setup. One big difference you'll notice here is, well, instead of putting tasks directly into an SQS queue, we're uploading our data and the instructions for processing it, those are called executables, by the way, straight to Amazon S3.
S3, right, that's Amazon's cloud storage. Super reliable, right?
Exactly. Think of it like our pantry. We're storing all our ingredients, our data, and our recipes, the executables, ready to start cooking. And now, here's the really cool part. Remember our Lambda function, just waiting for its cue.
Our domino triggering hero.
That's the one. Well, uploading our files to S3, that's like tipping over that first domino. It tells our Lambda function, all right, time to shine.
So now it's not responding to a tag on an EC2 instance, it's responding to new files showing up in S3.
Gotcha. Exactly. And it's got a new job now. It gets to call the shots with our auto-scaling group.
Wait, so the Lambda function is like the head chef now, telling the kitchen, our auto-scaling group, how many EC2 instances it needs to get cooking with our data.
Now you're getting it. The Lambda function is our orchestrator. It looks at the data, figures out what it needs to do, and then tells the auto-scaling group, all right, team, we've got a big one. We need, say, 8 instances to handle this efficiently.
And the auto-scaling group spins up those 8 instances, making sure they're all set up and ready to go. I see why you called this system elegant.
It's all about simplicity. Each part has its role, and they all work together. And there's another cool thing here. Remember our step function, acting as the conductor before.
Keeping all our serverless musicians in line.
Well, now our Lambda function has taken on that role too.
Our little code snippet got a promotion. So it's not just triggering the process, it's running the whole show now.
You got it. It analyzes the work, sees how many EC2 instances we need, tells the auto-scaling group what to do, and then sends those instances off to work their magic. Like the ultimate project manager for our serverless orchestra.
I'm kind of blown away here. We built a system that manages itself, that can scale up or down as needed, all while keeping costs down. This is amazing.
And the best part, you as the user, you don't have to lift a finger. No server provisioning, no capacity planning, none of those headaches. Just upload your data and your executables to S3, and the system takes it from there.
This is really incredible. But with all these moving parts, how do we keep track of what's happening? It seems like it could get easy to, to lose track.
You're right. Visibility is key, especially when the system is designed to run on its own. And luckily, AWS has a whole bunch of tools for monitoring and managing every aspect of our serverless setup.
It really does sound like AWS has us covered on the visibility front. I like the sound of that sophisticated dashboard you mentioned. So it's not a set it and forget it situation.
Not at all. You're in the driver's seat the whole way. You've got complete control and visibility. And remember those DynamoDB tables we were talking about? The ones that track the progress of each task?
Yeah, those are pretty cool.
Well, you can set up alerts so you get pinged if a task fails, stalls, or if it takes longer than expected. That way you're always in the loop. You can address any issues before they snowball into bigger problems.
It definitely eases my mind. But I'll be honest, all this talk about automation and orchestration, there's a lot to wrap my head around. Can we walk through like a real-world example just to see how this would play out in practice?
Okay, let's say you're a financial analyst, right? And you're working with these huge, massive data sets of market data.
Yeah.
Stock prices, trading volumes, economic indicators, you name it. You've got to run these complex algorithms on all that data to spot trends, make predictions, and figure out those winning investment strategies.
So in the old days, I'd be glued to my desk, just waiting for these really intense tasks to finish chugging along. Or I'd be hounding IT to get me more processing power.
Exactly. But with this setup, no more. Picture this. You've written this awesome Python script that has your brilliant market analysis algorithm, and then you upload that script along with, well, with your mountain of market data to your S3 bucket.
And that's it. That simple upload kicks off the whole shebang.
Yep. Uploading those files, it's like that first domino, remember? Our Lambda function, the conductor of this whole operation, sees those new files in S3, and bam, it's showtime.
Okay, so our Lambda function sees we're ready to get down to business. What happens next?
Well, the Lambda function checks out the data, and it can tell. This is a big job. It needs some serious computing power to get things moving. So it goes straight to the auto-scaling group with instructions.
Something like, hey team, we're going to need all hands on deck for this one. Fire up 10 EC2 instances, stat.
You got it. 10 EC2 instances ready to crunch those numbers. The auto-scaling group starts working its magic. It provisions those instances, makes sure they're configured right and that they're all prepped and ready to go. And then each instance gets a piece of that market data and starts running your analysis script.
So instead of one poor instance trying to handle all that data on its own, we've got a whole team working in parallel.
You got it. Way faster, way more efficient. And remember those DynamoDB tables we talked about? The ones that keep track of everything?
Right, like our serverless supervisors.
Exactly. Well, you can watch the progress of each instance. You can see how much data each one has gone through. And this is key. You can spot any potential bottlenecks.
And if one instance decides to take a break, our Lambda function can just spin up a replacement. No problem. No drama. The data keeps flowing.
Exactly. And once all those instances, all 10 of them, have finished their part, our Lambda function gathers all those results, packages them up nice and neat, and sends them, you guessed it, right back to your S3 bucket.
So I can just grab the results from S3 whenever I'm ready and uncover all those juicy market insights, all without having to touch a single server.
And that's the beauty of it. This is just one example. The possibilities are really limitless. Any task that you can break down into those smaller independent chunks, it can benefit from this kind of serverless architecture.
So what you're saying is I get all this flexibility, the scalability, and cost savings without having to turn into a cloud computing guru myself.
Yeah.
It's like having my own personal IT squad working behind the scenes.
That's the idea. Serverless computing, it lets you focus on what you do best, whether that's analyzing the financial markets or, creating that next killer app or even just getting rid of those tedious, repetitive tasks that eat away at your time. It's all about working smarter, right?
Couldn't agree more. This has been an amazing deep dive into the world of serverless scheduling and auto-scaling. I'm blown away by how such a complex, powerful system can be orchestrated so elegantly. It really opens your eyes to the power of cloud computing and just what it can do for businesses and, well, for everyone, really.
I totally agree.
A huge thank you to our expert for breaking this all down and showing us the benefits of going serverless. And to everyone listening, I hope this has you thinking about how you can use these tools to build incredible things. Who knows what you'll create when you're not limited by the old ways of doing things. Until next time, keep those minds sharp and never stop innovating.